So in the earlier video, we talked about what kind of patterns can be mined. And next here, we're going to talk about evaluation of patterns. So the key question that we ask if all mined patterns are interesting, and we know they are not, right? Intuitively, that we know they're not all interesting. For example, association rule mining, even on a small data set, you can easily get thousands of rules. And it is hard for any human being to read through these thousands of rules, let alone to evaluate their goodness or how well they're going to help their problem. So earlier we mentioned what the goal of mining is to mine non-trivial, implicit, and potentially useful rules, right? Not only some rules may not be useful, even those useful rules may also have some constraints. Some rules may fit in only certain dimensional spaces. Some other rules may not be representative or like a robust rule that you can apply anytime. It may be transient, it may be accidental. So we definitely need a way to evaluate all those patterns, whether it's association rule or it's a classification result. In terms of classification, it's the model that we would evaluate whether this model performs consistently well among different but similar scenarios. So evaluation is very complex in data mining because a lot of knowledge mined need to be assessed using objective measures or metrics, but also using subjective metrics. And sometimes subjective metrics probably is even more critical in terms of whether this knowledge is usable. Objective measures, you probably all heard of those. Accuracy, for example, precision and recall, false positive, all those measurements are considered objective. Once you have the result, you compare to the gold standards, and you know how well the system performed. Even when you don't have gold standards, for example, clustering analysis, we still have objective measures. Those measures would be how tightly the clusters are, how similarity of the within group objects versus the similarity of cross group objects. So those are the objective measures that we can use to evaluate the soundness of the system's performance. But in terms of the mined knowledge, whether they're useful or not in reality, that's a different story. Sometimes the objective measure may be low. You have 70% precision recall, sounds not very high, but it's already informative, so it could be already useful. Generate certain clues that decision makers could actually use to improve their operation. So subjective measures, including goal-oriented. What was your goal when you mined this? Does this knowledge answered some of the goals that you set? Whether those knowledge mined are actionable. Can you convert those knowledge into actions that you can perform in your everyday operation? For example, in shopping cart analysis, we know those two things co-occurs, but it does not answer you the question whether you want to put them together so that customers can just grab them, or if you should put them far apart, give customer more exposure of your other items when they try to reach the object or the product that they want to buy. Subjective measures in some of the scenarios when our interest is about novelty, we want to find something that's unexpected, novel and new knowledge. Then this unexpectedness could be used as a way to evaluate the patterns. But all those subjective measures are hard to quantify. So it's hard for you to use subjective measures to compare system performance. So in this class, even we want you to be aware those subjective measures are very, very important. However, really, we spend lots of time talking and doing objective measures. We report accuracy, precision, recall, and all those measures on our mining systems. We mentioned, and now we emphasize again, interesting patterns need to be potentially useful and they should be novel. It's not already known. And also we want it to be valid under the context of data mining, the prediction models. We want the result to be valid on new data with some degree of certainty. We test the data on the current examples, but how do we know if the system is going to give us similar performance if we give it an entire new data set? And this is a key challenge, still remains a challenge in data machine learning community, that the portability of machine learning algorithms is still kind of in an open research area. You have heard reports on those various deep networks, and they perform well, and they perform well in a set of data set. If you move it to a different data set, the performance drops, and sometimes dramatically. So we need to figure out ways to make the system work and have some degree of certainty when we use the system on a new data set. We're going to talk briefly on some of the methods that to help achieve this goal later in the semester. Another thing that I want to emphasize is the interesting patterns. Well, they have to be useful and they has to be valid, but they need to be understandable by humans. I think there's lots of concerns on large-scale data mining that actually could hurt individual persons. Your loan request being denied because the algorithm says that you are not going to repay your loan. But how does the system make that decision? If we don't explain that to this loan applicant, it's not only going to be hurtful, it's just not, to me, it's not just a valid reason to deny an application when you cannot explain. You cannot just say the algorithm says so, but to what extent can we trust the algorithm? So I personally really think a lot of methods need to be understandable. For example, decision tree give you a very good model that actually provides you understandable result that you can actually explain why. Neural networks is not really interpretable. In most cases, you don't know why you've been categorized because 10,000 of parameters that leads to that conclusion. So it's hard to give you a concise and informative explanation. Some objective measures for association rule, because we talked about this, right? Earlier we looked at association rule, we look at support and confidence. And when we select association rules, we use support confidence threshold. We could use other threshold of other metrics that we're going to introduce later to measure association rules. So position recall measures are not really applicable in association rule because we don't have a gold standard. We're talking about how strong the associations are. So we have different sets of objective measures for association rules. And for clustering, as I mentioned earlier, there will be a different sets of objective measures to measure the goodness of clusters. So for classification, we talk about this if-then rule, accuracy, and coverage. Well, if we have time, my slides already included if-then rules, and those are the decision list. We can certainly cover those as one group of things that you can actually measure those rules with accuracy and coverage. More details will follow when we get to there. Okay, this is the end of my short video for pattern evaluation. Oh, I want to mention that depending on your data, not everything is, we already made that point, but especially for accuracy. Later, we're going to talk more about this. When you have very imbalanced classification problems, accuracy is the measure that you want to avoid because it will not give you an objective measure. And in terms of evaluation, I should also mention that we cannot just use one evaluation matrix obtained from one run of the algorithm as the representative performance score for the algorithm, because it can be accidental. It's depending on what training data you fit into the system and what test data you test the system on. Therefore, the evaluation is not just one number. We need to obtain multiple scores and perform statistical analysis to test the performance improvements and to see if actually those make significant difference. Okay, I think those are the key points. I'm going to end this video now.